Welcome to the June Data Simplified event. And this month we're going to be speaking with Priya Sarathy about big data challenges. And so, Priya, do you think you can give us a little bit of a background about you and why we asked you to join us for this big data subject, please?
Okay, I think, Nancy, first of all, thank you for inviting me and giving me this opportunity. Well, I should ask you why you chose me, but I can tell you my background so that hopefully will give a context to the topic from my side. I actually started off as an econometrician, which means applied economics to data and trying to figure out what is really the data about. And that is something that has influenced me throughout in how I look at data, how I use data, how
Mhm.
I design solutions against it, and how the solutions will have an impact on either the business or any other context. So, that being said, I have had to work with tools as they have evolved over time. With many of the companies that I worked with, they were always on the cutting edge of technology, whatever that cutting edge meant in that age and time.
Right.
And usually it was always evolving. So you did not have the perfect scenario. You always had needs that were greater from the data point of view, needs that were greater from the tools point of view. And then you had to design the solution within those limitations. You had to try to kind of reframe the context and reframe how you could use and what the limitations of what you could create. And so that being said, most of the companies in the past I worked with IBM and AT&T. AT&T was with the global network. IBM was with all the users across the world for this hardware and software solutions. And designing analytical assets, from the predictive point of view, for optimization point of view, required, in a sense, a very close cousin of the big data of today. So,
Hmm.
in that sense, you were always trying to see how much you could use your existing analytical tool sets and existing environments, to say the least, and the people skills and everything that go with it to create a solution that responds to the request of your customer. So from that point of view, I have always been working with the not so mature but evolving techniques, but it has always been a matter of adapting or adopting how and when to do what. And that has kind of been tuned in. So now if you fast forward, the most recently I worked with a company that had tons of data on individuals' personal data, which I was working in identity and fraud detection.
Hmm.
And in that space, the more data that you have, the more accurate your models can be. So in the ML models that we built and ML processes that we built, we were really handling big data and big data challenges as we define it today. So that's kind of my background, and
Yeah.
I'm open to answer more questions on this as we go through the talk.
No, yeah. Well, thank you, Priya. I love that like full overview. That's fantastic. And how things have changed and how you've had to evolve with it, and help the companies that you're with evolve with it as well and change and meet the challenges ahead. So because you brought up big data and challenges that you were addressed, let's start with that. Let's go to the first like big question here. So let's demystify big data. What is it?
So in about we started about the new generation of internet and the explosion of internet usage. I think about around 2000 and around that time frame. And what was happening was the technologies were catching up with the concepts and the thoughts of how you could use and work in this internet world, right? So you had early people, the Yahoo mails or the Hotmail,
Mhm.
people got these free accounts and they were, really gung ho about using it. But in that process, they started generating a lot of data.
Right.
real-time data started flowing in, that you needed to have technologies to store them effectively, to access them and use them. So the big data uh, concept evolved from the technologies, and the technologies in their part also evolved further to handle and deal with big data. So it was this kind of a symbiotic growth that we kept seeing between 2000 onwards, till we came to the well-defined construct of what is a cloud, right? Big
Mm.
data and cloud became quite synonymous, because to hold big data, you needed the cloud to have the kind of the efficiencies of scale and scope and compute power. And
To
so,
support all of that. Yeah.
yeah, to support all that. So, if you were to go back to the original definition, I think yeah, IBM kind of coined the term of 4 V's, and I think it has been expanded and interpreted by many other folks. But basically, big data has four critical components. At least three of them are most critical. One is the volume. With the internet, coming of internet, with the e-commerce and all the information that was kind of being built at the e-commerce interfaces, we started seeing large volumes of real-time data being created every second, every minute, or even less.
Hmm.
So that was the concept of volume. And the second one related to do is the velocity, which meant that it was not something that was produced at one point in time, but continuously at a very rapid pace. So it was like, you open the floodgates of a reservoir or a dam, and all of a sudden, boom, you get big amounts of volumes of water just hitting you. And that kind of created this concept. Well, we have never done this so fast, because traditionally when we built models, we would access these data. It's almost like a leisurely stroll through an enterprise. Okay, I like this, how do I make use of it, what can it be? I investigate it, I do EDA against it, identify my business use case, and try to find the approach that matches the two. And it would take us any time between couple of weeks to a couple of months to get that done. But with the high volume and high velocity, we have to start thinking about how we change our approaches. Okay,
Mm.
so those were the two pieces. The third thing is variety. Wow, I think when I started off, I think when I was working with IBM, we had customer data. In this case, this was a business profile, Dun and Bradstreet. And then we
Right.
had other internal data which we could track purchasing patterns, you know, uh, uh, relationships with a customer through sales and things like that, which is historical, and that allowed us to build these models based on behavioral buying patterns. But now when you move on, you have internet, so you have an online presence, and people are interacting with that online presence constantly. You have information that's being gathered at which page did the person spend most time, how much did they spend time on a certain line, a certain set of information, or a certain offer that popped up. So you're collecting in real time logs of all the interactions in your company, in your organization. And that is just a different type of data. It's a log data. It's a different type of
Mm.
construct, structure, and well, that is just to kind of go back to things that could be structured. But
Right.
then we also had unstructured data with the internet. You had
Mm.
the images, the videos, the audios, the movies.
All of it.
Now you have a huge variety. So those are the three, I would say, the characteristic of big data, but they also create challenges of their own. The fourth one, before we kind of move on, is veracity, which is you have all this data,
Hmm.
you got to do something with it. But to do something with it, you got to have it organized and be made have a good quality. The veracity of the truth. How good is the data? Okay, so if it is not good, there's nothing you can use, and
But you
all
need
of
to
it
get
is,
the
yeah. So those are the four things that I kind of feel define the big data in its very, I would say, almost multiple personas, and each one is something you have to handle and build a relationship with as you try to plan your usage of that data.
right. So so how does So those four aspects, how does the big data affect your ML processes, your decisions or data driving decision making? Can you speak to that?
Absolutely. So to kind of set the stage, uh, let's just look for a minute at what the ML processes does compared to what we were used to.
Mhm,
When big data didn't come in, we were, as I explained earlier, we could look at the data, work with the data, and you kind of supervised learning is kind of the new term, but that's what we did. We built models that were supervised by us and enabled by us working with the production team. You kind of threw it over to the IT tech folks, and they would recode it and say, hey, now we can put it into our pipeline, right?
mhm,
And then you would go back and forth saying, hey, it doesn't look like what I expected it to look, so on and so forth. So when big data
mhm,
came, it kind of opened the eyes of everybody. You were always constrained with little data, and you had to try to think about ways of sampling it. But when big data came, the options opened up. So I don't have to limit myself. There's so many other things that can be happening, the patterns that I may not have observed, and I can build more solid models, more accurate, more robust models against the bigger samples if I chose to, or go against the raw data if I had to. So now the question became, how do I handle it? And which is why the evolution of machine learning processes and algorithms came into being. So it was kind of merging the probabilistic aspect of building models and looking for patterns and building predictions with the efficiencies and the computational advantages of the machine. So when the two came together, this was really great for doing and handling big data because it removed the challenge of me spending 3 months going through
mm,
iterations of the model.
right.
So now you had this algorithm that could run through 1,000 iterations against your data set and identify the features which are most important, which are which inform you more about the hypothesis that you've set up for the model to, run against. And in that process, you can basically see your months kind of reduced to seconds, right? So
Mhm,
that being said, you could use these models in different ways. So, the challenges that typically come with machine learning processes from big data is if you were to go to that raw data directly to feed your models, then you are missing an important aspect of the big V, right? Four
mhm,
V's, the veracity. The quality issue becomes something that you may not be able to control. Because as raw data comes in, if somebody messes up with the data or something kind of is you can call it poisoning or contamination, then that, if you don't monitor and catch that in time, it flows through your model, it flows through your decisions, and whatever services
mm,
you're delivering gets into. So that is a big issue that one had to think about after the feeling of elation. I said, I have so much data to work with, right? So that becomes one key aspect of the big data challenge that one has to look at when you're designing machine learning processes. The second actually comes from the second aspect, that is the velocity, right? Um, Typically, machine learning processes, you can enable them in different ways. You typically would have started early on that you would create a batch ML process, you score your models, and then you load them into your systems, and then the scores are used to generate the services or product support that you need. That would have been one way of using ML model. The second way would have been if you create these models and score your data source offline, but then they become available for on-demand decisioning. And in
mm,
that case, the example I would give is where I was working in is identity authentication or fraud detection. Now,
right.
these are real time. So somebody pings your system, right? And says, I need to kind of verify whether this person is who he or she they say they
As
are,
they are.
you
Mhm,
know. For that, the more real-time information you have, you can be more confident and comfortable that when you are creating a recommendation, yes, Priya is who she says she is. Okay, I can then fill up my new account applications, right? That is the value of having real-time decisions being made, but you need to have access to those models and algorithms in real time.
Mm,
On the other hand, when you talk about really real time, where machine learning systems are part of information flowing in, they have the checks, but potentially have some checks on quality, but that data is flowing in as the requests are being made against it. The decisions are very active. That is real time, and there can be so many issues that one has to be really, really on top of in terms of
mm,
monitoring. Uh, an example of a real time, I believe you could think about TikTok.
okay.
As people see, think about it as you go to a TikTok and you catch on and you like a video and you go through two-thirds of it, then you start abandoning it and you lose interest. Obviously, you get little recommendations. Perhaps you like this reel, perhaps you want this. Those are real time. They're looking at what you're doing, how long you're spending, and generating new content for you to keep you on their
If you engaged,
channel.
yeah.
Yeah, keep you engaged. So
Right.
those could be what is real time, but then you have to deal with the volume of information you're processing, the and the way you process. So there is a data bias that you have to be careful of. But then again, you have to also be sure about the models. you know the need for that
Mm,
monitoring is so much more important with big data, because data could change over time based on changes in pattern and behaviors in the
mhm,
normal world. So that biases in data can actually feed into the models and cause what you could define as a model drift. So the models are not really tuned properly. I think about
mm,
this, Nancy, as tuning a piano, right? If
right.
you're a musician, you want to be very, very careful that when you press a certain note, that it is what it should be.
Was,
It,
yeah, exactly. The output
so,
should be
yeah.
exactly what you expect it to be.
So that to me is one of the other aspects of the big data which impacts machine learning processes. So, okay.
Mm,
So, okay, where are we? So we did the data, we've done the model, and in between the data and the model, there is also features. So the third aspect of big data is the ability now to design these pipelines that will run through the data and create the features that you can now hold in a repository. Okay, because think about it. Uh, and the reason why I feel really that this is a critical piece of any machine learning process in a world of big data is
mhm,
because the volume of information and the velocity with the information comes in is kind of hitting you with this big crash every second of the time. The question for really any organization becomes, I have to store this somewhere
mhm.
till you're ready to use it. There are two implications of that. If you store it and you don't use it, you spend money for no
Of
reason.
keeping it.
Yeah.
Yeah.
And the value of the data is lost. So why have big data? Well, that was the whole point, is the volume and the velocity, but you're not used it. So you have not changed anything downstream. So if you were to store it, then the question becomes store what you need and store what is relevant, right? So that is where many companies, it is really surprising that you move to the cloud and say, oh, costs are going to fall. And before you know it, with big data kind of pouring in through all the different channels, you say, oh my God, this is really expensive. We need to be a little more economical about what we do with data and really need to think how the best way to save this. That is where the feature store becomes very critical. What feature store becomes, it's like a staging area.
Okay.
So data's coming in. like the dam, the reservoir, you hold it, and when you need it, you open the dam and let it through. So the feature store is a repository of information that has been transformed, aggregated, or computed otherwise to create the information that is relevant to your model.
Mm.
So, why do we need that? Well, back to the first part of it. You don't have to store as much because all data may not be useful. So you may
Mm.
have 5,000 fields of data coming in of, well, what do you really need from a log file of who visited your website? Maybe the person who visited, the time who visited, how long they visited.
Yes, they
You have
right.
a
That's
lot of other little items in the log fields which you may not record, that you may not need, you know so why keep it? It may be repeating the same information that you send them and appending it to the log file. So we need to think and design these features very strategically speaking from 2 points of view to make the data, use the data properly and transform it into relevant fields so you extract all value from the data. And then you reduce
mm,
your storage issues because the more you store, the more you become sensitive and vulnerable to data hacks and things like that. So you
attacks
don't,
and the thing
yeah,
like
yeah,
yeah,
attacks. You also have that as a CTO or a CISO. You have these things
very
going on in
present.
the mind, right? Very
Absolutely.
present in these. These are real time issues. So you got to kind of build that balance. So that's how, as data scientists and product team people work together, they can then realize how to extract. I think there's actually a book called Data Juice, but I will use that same term, how to extract the juice from the data. I think Doug Laney, I'm sorry, I need to give credit, Doug Laney, who wrote the book on data juice. But how do you extract the juice from the data and retain it in a form that can be used? So
Mm,
that is one of the reasons why I really think that creation of that feature store, a feature repository, has been incredibly useful for machine learning processes to handle this big data challenges. The other thing that I also find characteristic of the feature store is, okay, you collected this data, it is there. Now, when you get a real time request that I have to run this model, right? Now, if you were to do it in a very traditional way with the other repository, feature repository, then it would kind of, the service would ping the systems and the system will say, well, you know what? You need data from this table, this, 5 tables or 10 tables. Well, then you say, okay, I take that, and then you go to the, I mean, I'm not saying physically, but this is the system flow.
right.
The
Yeah.
system is, processes are going to dig and touch those data tables, extract the data, and bring it back to the model. Then the model computes the value of a score or the decision based on decision rules and delivers a certain service or a product. And if you take the example of identity authentication or fraud authentication, it says, you know what? We have looked at all the data available. This person does not look suspicious at all. I don't see him as a fraudster. Go for it. Do whatever you have to working with this person.
For this person. Yeah.
Yeah, in that scenario, the SLA becomes an issue. So you're opening an account. I've had this experience. I don't know if you had. You go sit down in a bank and you say, okay, I want to open an account, a new account, a checking account. And they say, okay, we'll take down your information. And they say, we need a verification. And they're waiting and they're waiting and they're waiting. And you can say, if this is the way they're going to handle the process, what happens if I want to interact with it online? Is it going to be so late? So keep that in mind.
Right.
And that kind of
Mm,
frustration builds up. So the
right.
SLAs on real-time decisioning are very, very low. 250 milliseconds, more than that, 300 milliseconds is very, very low. So the more time the request or the query goes to hit the data and retrieve the data, it adds to the SLA, which can be detrimental to you as an organization offering an online service.
Right.
So
People will
what?
just turn away.
Yeah, I mean, it's like, okay, I'm going to a different page. I've had this with this bank, or I have this with
Exactly.
this page. I'll try to look for some other online commerce channel. So in that scenario, what Feature Store does, is it cuts the time you have to go and search through a really long table of historical information. And the example I would give is if I were to create a feature that says, I want to know if in the last 2 days or 3 days, starting from today, whether I saw any activity that was suspicious against this person in the data that's coming in. Now, I have a lot of data coming in. It could be 200 million records or inquiries coming in that I'm looking through multiple different sources. So that can take time. And
Mm.
that could really bring the system, the process down on its knees.
Oh, for sure.
So when real data is coming in, or not really, big data is flowing in, if you capture and store only those 1 hour incrementals of aggregated information, then when your request comes in, you just capture that, grab it, and maybe you may have to do a little more summarization, but that's a shorter time frame and a
Absolutely.
shorter set. It's a smaller
Hmm.
table, narrower table. And that allows the ML process to be more productive and efficient from a time computing perspective.
Perspective, yeah.
So those that's a third feature of the big data that the creation and the use of this feature repository has really allowed us to manage some of the challenges. Okay, so that's I think we gone through data, through the feature store, then the model.
Yeah. Very good. Thank you.
Okay, so the last bit is of course the outcome of the model,
Yeah. Okay.
and
Hmm.
that is how accurate it is. And I think that aspect of it rests on, I would say, how well you are monitoring it, how well the feedback information is being checked. And because remember, it's a machine learning process, it's learning. If you have it in real time sitting in that space and you're not really touching it, it's running through the cycles, then you want to know what data is going back, how it's feeding
Hmm.
in, and how the learning process is taking place, or if it is gone rogue. Those are things that
Mm.
you really need to monitor. So,
So I'm glad you brought that up, Priya, because you talked about that ML and it's a learning process. So because it's something that's constantly learning and changing, so how, like in terms of development, how do you sustain an innovative and relevant process? Like how do you make sure you keep that in check?
that is very good. You know, good question. So, what do you mean by innovation? You had to start from there, right? You have machine learning. Okay, so I'm a data scientist. I worked in building this new process, and it's going to help me detect fraud, for example, much better. Okay, so I've done that. And now it's been enabled. I have made sure, or one thing I didn't touch earlier is the technical issues of, can the infrastructure and environment actually handle all of this?
Handle
Yeah,
the
so
processes. Yeah.
I'm kind of focused on the data piece of it, but I'm taking for granted that everything works fine, which is typically not the case. There are always
That's the case.
glitches. Yeah.
Yeah.
So anyway, so now I going back to it, if I have built a process and I have decided that a model or a group of models all together help me answer the question or the and deliver a decision to a customer based on a decision rules at the other end of the model, right? How would you innovate? Now,
Mm.
the question I said is the feature. Let's start with the data. It is maybe there are some aspects of the data that you did not consider of value.
Okay.
So as you go through the learning process, you are monitoring it, you're looking at what it's doing and what it is saying, how the decisions are being made. Now, maybe you're seeing that there is some kind of a duplication across models, which you may not have noticed, but maybe that is something you monitor. But then
Hmm.
there also the scenario of honing in on the kind of data and how the data creates the feature, right? So I know some companies actually have machine learning models to kind of create the data, the feature engineering, the feature. So the feature engineering becomes its own process whereby you are creating features that may be relevant to the current context or maybe have a different application on a different context of use case.
Mm,
And how do you kind of make sure that with all the features you're creating, and I think at one point we built about 4,000 features, that we are not overfitting or kind of using features that overlap and say the same thing, and so everything looks even more red and beautiful than before. That is something you have to be careful for. So by creating good metrics and measurements, it allows you to see where things are working best and where you can improve. And those
mm,
little changes is what I can say gives the first approach to innovation, right?
okay.
The second would be you have built the model and you know the context with which you built the model. Trying to rethink about the context. If the context changes, would you have to change the whole process, the whole model? Or can you add something to it so that you can have the relevancy in the new context? And so, look out here, you're looking at different types of services that you can branch out that can be used.
Mm,
So, if I build something for an authentication process, or maybe let's take a different example. Suppose we build a certain type of car, okay, one of these driverless cars. So once you built it, it's built on a lot of models behind the scene that are working in tandem to get the information and kind of have a prediction or a recommendation of what this car should do, whether it should turn left, right, or stop. But the same technology based on machine learning models can be used to drive other types of vehicles as well or other types of services, like maybe it helps with a wheelchair.
mm,
Not as complex, but the same piece can be used in context with another product, which is not a self driving car, but it could be a wheelchair where folks are not able to, physically challenge, but they could have hand motion also could be limited. So, you're kind of interacting with the system that reads your either the mind signals or your eyes or your speech patterns and is able to help you navigate. So so that's what the innovation comes in small but little forms as well.
mm. Okay, thank you. So, Priya, you talked a little bit about how you have to be constantly checking and making sure every step of the way is working as it should and making adjustments as needed. And you also mentioned CTOs when we talked a little bit about risk. And we'll revisit risk in a moment. But like who should be like what should the leadership team, you know, who should be a part of it? And to make sure that the big data and the projects and everything is being aligned as it should. Like what teams should be talking to each other?
Okay, so you asked me two pieces of information. One is the structure and who should be talking. um, I think the talking should be everyone. So
Okay.
and we can get into that more. But the structure is very difficult and it's going to be very much focused on trial and error, literally, because a hierarchy of responsibilities depends upon domain knowledge, who understands
Mm,
what, how is the organization operating, how do they operate, how are the interactions. So it's kind of difficult to pinpoint one success. But
mhm,
um, needless to say, I mean, I've been exposed to many different types of organizational structures. Sometimes they work, sometimes there are conflicts. But that goes to your second point, is the communications.
mhm,
uh, in a sense, think about it. You have, three legs of a table, as usual, or of a stool, not a table. You have the data folks and the technology folks. You have data and analytics, and I'll put product underneath it too, because they are kind of working in tandem. in materializing whatever they want to do using analytics or using ML processes. So all that is in the holding the stool up, but sitting on the top? It's the people. It's your end users, it's your customers, it's your uh, individuals who are providing you the insights to do what you have to do. So maybe we can even put the product team in there and they're sitting on the chair, on their stool. So the question becomes, if you have one master, supposedly the product, because they are focused on the business outcomes, they're focused on revenue growth, then the other three need to work in a very collaborative manner
Mm-hmm.
to focus on the goals of this customer, this product team, or this customer, or whatever you want to market. And that typically means that you could be in three different organizations and still work together if you're really good at communication.
If,
But
big if.
that never happens.
Mm-hmm.
and and I think it's all, what I think is, some of the bigger companies have had to deal with culture, right? The typical thing that culture is strategy for breakfast. It is very relevant. It's very relevant because there are folks and resources and people, personnel, who have not made that change, who are reluctant to make the change. Think about it. When I talk to you about the example that I would be in charge of a data science team, we would build models and then we would give the models to the production team, then called IT team, and they would convert it. So they had complete jurisdiction on end to end of the pipeline.
Mm-hmm.
I would be called in as an expert to consult to make sure that I approve and I'm willing to take ownership of the outcome after they do whatever they have to do. But that is no longer the scenario today, right? Machine learning involves technology. It involves the data science of building models and understanding the domain of the product or whatever that you're building the context against. Data is a really big piece that nobody really has not bothered till recently to really understand and to manage it. So data governance and data quality now will come to bite us even more when you have these machine learning pipelines. They're autonomous. They can just run day in and day out, even if you take your weekend off. And what that means is, earlier, I would be sitting on top of the data to make sure I programmed the what data I wanted to go into production. Now with big data, I have no control over it. It
Mm-hmm.
is flowing in the weekday, it's flowing in the weekend. So data governance and data management are kind of something that have become integral to the modern processes in analytics, in machine learning, and AI, whatever you call it. So that piece of the stool is something that we used heavily, we leaned on heavily, but never really paid it enough respect.
Mm-hmm.
So going back to the org structure, so I really think that because that's very technology based, because you're talking about ingestion, maintenance, validation, all based on technology that ensures that the volume and velocity is tied to and the variety is tied to the veracity of the data. You would think that sitting inside technology, it would make great synergies happen and everything would work itself out. That works in our experiences. When it doesn't work, you
Mm-hmm.
know it really decides on, and comes back to it, that the technology folks and the data folks have to learn to work together in a way that is collaborative and productive towards the same goal. I think the
Mm-hmm.
same way I've seen um, conflict from the data science to the technology world, because technology folks would say, we know how to do these pipelines. There are standardized modular things we can use. Just tell us what you want. Well, good and true, but what about the feature engineering? Or we can set up a
Mm-hmm.
fine pipelines. What about the design and the definitions of the feature? Because it has to be make sense. Remember, you're going to take big data, condense it into a comprehensive manner into a feature repository in context, with context for tomorrow or day after, whenever you want to use the data. So that connection, because now you don't want to have one person or one team have to specialize in all five. That is why we have the three legs of a stool. So I think we need to kind of understand each other better. So whichever way the organizations are structured and held, they need to be responsible to one another, respectful of one
Mm-hmm.
another,
Mm-hmm.
and want to learn. Just because you're learning doesn't mean you know it, right? And I think if one goes in with that kind of an attitude, that communication and collaboration, I think it'll be easier for the person sitting on the top to feel confident. Otherwise, you're kind of going teetering between left, right, and center. So I don't think there's one answer that I can give you. I have seen where data science and technology and product all came under technology and data, and it seemed to work for a short time. And then there were issues because I think it's all in the mindset. It's all in
Mm-hmm.
the leadership, how they bring the project to its life, how they bring it into the space of, hey, we need to be open, we need to collaborate. And we may know some things. If we know it, we can share it. Because it is
Exactly.
that sharing and learning makes each of us innovative. And going back to the point of innovation, I might see the information a certain way. I have modeled and trained this model in a certain way. But it may take somebody from a technology team to say, you know what? If you made these slight changes, you could do a much better job of monitoring or much better job of efficiency or SLAs because it's a cost. It's not just
Right.
the output and the decision, it is how you do it, how long it takes you. It's a lot of different things that your model has not, and you as a data scientist has not considered. You as a data officer may not have thought about, data steward may not have thought about it. So innovations can come from everywhere because somebody who's stepping out of the loop can see things a little more differently. And that again comes with communication. So innovation is very closely tied with awareness and communication.
I liked what you mentioned about culture and the data culture. Sometimes infusing that or bringing that in has its challenges in itself, which is an entire other subject. But communication is a good start for everything, so that everyone, the right people, are talking to each other, and a project will succeed if there's good communication amongst the right team. So thank you, Priya. That's good. And just before we wrap up, because I know the time has flown by, I wanted us to talk a little bit about risk. When you're designing things, when you talk about, an end product and the ML environment, can you talk to that?
Absolutely. And I think risk is in everybody's mind because of
Mm-hmm.
what we are going through, as now it's termed as AI risk, and the traditional ethnic biases of the data is more of a social risk that we are facing from the new AI tools. But if you look just at a machine learning tools and processes, risks are going to come from everything that I mentioned before. There is the data risk from the quality of data, how you use the data, how you build train your models. There's going to be a risk that you train it for a purpose and you use it out of context. You know,
Mm,
application of this. So that's why I said when you think about innovation, it's also creating a risk. You know, who is using the process for what kind of recommendation? At the same time, you have this is the quality and bias. Then you have the regulation. And that's something one can't handle in a model, but one needs to have uh, guardrails that mitigate the potential of violating any kind of regulation. There's a lot of regulatory laws and rules that
we have to
play
keep in
in the
mind.
financial. So yeah, we have to keep in mind.
Mhm.
Uh, then there is the actual management risk is how you manage the whole machine learning process. And that's where the monitoring becomes very critical and timely alerting, right? If something happens, if you are in the process where you leave the system unsupervised, there is inquiries coming in from on online channels, applications being accepted based on machine learning models that look into your
Mm,
data and say, okay, you meet 9 out of the 10 criteria, so you are eligible for a certain offer. So that is something that's going to happen whether you are looking or monitoring or not. So need to have
mhm,
timely alerts to indicate that is kind of important. So basically management risk, oversight or lack of oversight is going to have create risk. And then finally, most of the machine learning processes feed into a decisioning engine typically,
mm,
and there are rules that can get outdated. So even though all the
mm.
stuff you have been building up using data is relevant, the rules may get outdated.
And
And
you'll have
some,
to adjust to those.
yeah, and that is a big risk because the fingers can easily point at the data person, at the data scientist, and the data engineer. But guess what? The product team that manages business rule did not update their decision rules in time. And so the customer got something totally different. So,
Mm,
each point of view, it's that monitoring that is helping with the risk. But then, as I mentioned before, there's model biases and data biases that really has been the focus of much of the discussion for Gen AI, which is different, but still, those same kind of elements have application in what we talk about big data.
Right, thank you. So before we conclude, any last words on best practices, tips, things that companies that are currently facing challenges or big data challenges ahead, they'll watch this and they want to know, takeaway. What can you give us?
I think there were two things that I'm most passionate about,
Okay.
and that is the communication and culture
Mm,
piece.
yes.
I think uh, the bringing everybody together to discuss things jointly in a fair manner, in an open manner, always helps teams to feel confident that they attach to the project, they attach to the process, and the commitment is more there than if you select to exclude them in certain relevant discussions. So maybe not
Mm,
everybody has to be everywhere, but
mm,
that keeping that information flow going, because most of the machine learning processes, ML ops team have to interact with many partners, technology, data science, product, legal, security. So that communication helps everybody to be on the same level, and that allows for little issues to come up, be discussed, be resolved, and then move forward. Otherwise things
mm,
get lost and hidden, and people don't want to say, hey, I made a mistake.
mm.
So fail fast, which is what agile mentality. So I think that's one thing that I really really promote. And I would say have some happy hours together. Now that you're coming back to office, bring the
Yeah.
team together virtually or in real time,
Mm,
you know,
mm,
because making those connections often allow you to get multiple perspective, which one single person, one single data architect, one single senior data scientist, or one senior product manager may not have thought about. But having the ability to say, hey, let me talk to you again, communication, that I think will really, really change the chemistry and the speed in which productivity innovations can
I like that. I'm gonna take that happy hour. All right.
happen.
That was my takeaway. Thank you.
Absolutely.
Thank you. Thank you, Priya. So I'm going to share with everyone before we wrap up some resources. You have Priya's LinkedIn is on there as well. And there's a book that you're reading, Priya. You want to tell us a little bit about that?
Yeah, so I heard Kathy O'Neill speak at a conference recently in Boston,
Okay.
and I started reading her book, and it is a wonderful book that's kind of reflective. So she talks about weapons of math destruction, how algorithmic biases
Hmm.
can have a negative impact on people and their lives. So, one of my passions right now is to find analytics of social good. So, she has gone through many different use cases and looked and explored in her career how she noticed algorithms can benefit the rich and often act in a negative way to impact those that are not empowered. And so I think it's
Mm,
worth reading this book because given that we are talking about AI ethics and AI risks, and it could be ML risk too, to
right.
be we need to be responsible on how we build these systems, these ecosystems, and how we use them. So I think
Mm,
that's why I found this book really, really, really good. So I'm still reading it. I'm two-thirds of the way, but it has been quite a moment for me, just aha moment, as you put it, to kind of think back, pause, and think back on all that's been happening with algorithms. So
great. No, I love it. Thank you. And also because, and you mentioned ethics, so that's fantastic because the next podcast or Data Simplified event that we're going to have is at July 11th, and the topic is AI and data ethics for leaders. So I think the two will go really well. We're going to be talking about ethical implications of AI and data usage in business and how to navigate them. So please stay tuned for that session as well. Well, thank you, Priya, so much for your time. Loved having you on. This recording will be made available in the next few days, and so everyone will be able to replay and of course, her Priya, your information will be there. So
thank you.
look, you'll be getting comments and feedback from viewers as well.
Yes. Oh, I'm totally open to that. Thank you so much for having me on, Nancy. Thank you.
Great, thank you, Priya.